Okay, I'm ready. Okay, so here we are covering the proof of the Infima version of the completeness axiom. So we had the setup of S is a non-empty subset of R that is bounded below. S naught is the supremum of negative S. And the completeness axiom implied that S naught is a real number and exists. And our claim is that negative S naught, which is going to be a real number since R is a field, right? Negative S naught is our candidate for the infimum of S. So we're supposed to prove that since S is non-empty subset of R and it's bounded below, then the supremum of the infimum of S exists and is a real number. Okay. And so we have our little picture here, which shows kind of just a graphic showing S, the set S, the original set S, which is bounded below, negative S, and then S naught, which is the supremum of negative S. Okay, so let's see. So we claim that negative S naught is the infimum of S. In order to be the infimum of a set, you have to satisfy two properties. First property, you have to be a lower bound. And the second property is you have to be the largest lower bound. So first we're going to show that negative S naught is a lower bound of the set S. And what does it mean to be a lower bound? That means that any element in S is greater than or equal to negative S naught. So that's our goal. That's what we want to show. So we'll say let S belong to the set S. We want to show that S is bigger than or equal to negative S naught. But now if S is an S, then negative S is in the set negative S. And remember, S naught is the supremum of negative S. So that means S naught is an upper bound for negative S, for the set negative S, which means that the element negative S has to be less than or equal to S naught. And now we just essentially rearrange our inequality to get that S is bigger than or equal to negative S naught. So every element in the set S is bigger than or equal to negative S naught, and we can conclude that negative S naught is a lower bound for our set S. So this first implication results from the definition of the set negative S. The second implication is the consequence of S naught being the supremum of negative S. And the third implication is a consequence of arithmetic. So now we want to show that negative S naught is the greatest lower bound of S. Let's see, I think I skipped ahead too much. Okay. So to do that, what we're going to do is suppose you have a point, a real number, that's bigger than negative S naught. We're going to show that anything bigger than negative S naught is not a lower bound. So that should be lower bound. I'm sure I'll clear it up.
It's 12:45.
Okay. So what we're saying is that if you have any number that's bigger than negative S naught, right? So if t is bigger than negative S naught, that means that negative t is going to be less than S naught. And since S naught is the supremum of negative S, anything less than S naught is not an upper bound for negative S. So negative t is not an upper bound for S, for negative S. So then t is not a lower bound for S. So again, that should say it's not a lower bound of S. So t bigger than negative S naught implies negative t is less than S naught, which implies negative t is not an upper bound of negative S. I finally corrected it, yeah. Okay. And so what does it mean to not be an upper bound? That means that there's a point in negative S that is bigger than negative t. So let's see here. I think this should be there exists a q in negative S. So there exists a q in negative S, and q in negative S means negative q is in S. Okay, so t is not a lower bound for S. Okay, so good. So I found some typos that I made there. Oh, okay, that's it then.